So for today's activity, we're going to determine physical layer terminologies. Uh, this is the physical layer description, whether it's fiber optic, bandwidth, throughput, copper, and wireless. So let's begin. It's a media that uses patterns of microwaves that represent bits. It is wireless because microwaves is a visible waves that sends data other to other devices. So the next one is the capacity of medium to carry data. It is a bandwidth. Bandwidth is the capacity. Let's check. Bandwidth is the capacity of medium to carry data, which means that is the if the capacity is very high, uh, the data that can pass through the medium is high. And next is media uses patterns of light to represent bits. It's fiber optic. Fiber optic cable uses patterns of light, uses light to to light to represent bits or to send bits or to send bits or represent bits. A measure of the transfer of bits across the media. Bandwidth is the capacity and throughput is the measure of the transfer of bits across the data across the media. Next one is media that uses electrical pulses to represent bits. The copper the copper and fiber optic is both they are both they are both wires, but the copper is very different to fiber optic because fiber optic uses light, while copper uses electrical pulses to represent bits. So so that's all for this activity. I hope you understand something and you learned something from me. Uh, um, so I will end this video. Thank you for watching. Peace. Okay, on this activity, we are going to identify copper media characteristics. There's given characteristic, and we're going to click click on UTP box, STP box, coaxial. If the characteristic is for for those uh, for those copper media. Now let's begin. It attaches antennas to wireless devices, can be bundled with fiber optic cabling for two-way data transmission. It is coaxial. Coaxial cable mostly uses to on antennas on, on television to gather signal from other tower. Now, and, and also it can bundle with fiber optic cabling for two-way data transmission. Now, second one is okay. Let's check. It's correct. Now, second one is it counters EMI and RFI by using shielding techniques and special connector. STP, it is STP, shielded twisted pair, because uh, it has special shielding inside the wire to counter EMI and RFI. So the data not will will not in, will be not interrupted during the process. Let's check. It's correct. Now, the most common network media. By the way, uh, uh, the most common network media is the UTP or unshielded twisted pair because it is used mostly on RJ RJ45 or Ethernet cable. Uh, but on the other side, SDP was also used or was also used for uh, Ethernet cables, but it is more expensive than UTP, and SDP is harder to install than UTP. Terminates with BNC, N-type, and F-type connectors is a coaxial. Okay, thank you for watching this video. I hope you understand something from me. Uh, I hope you like my video and peace. Okay, for this activity, we are going to uh, determine the color of H wires inside the T568A cable pinouts. Let's begin. Uh, the first pair is in the middle here, and okay, check. Okay, it's correct. The second, the second wire color, the second pair is here. Oops, is here. Okay, the third pair of wire is at the very first. Uh, the colored first before the stripe. Up the I mean the stripe first. It's alternate. Stripes, stripe, stripe, stripe color, stripe color, stripe color. Then no, okay. This is the first pair, the second pair, the third pair, and the fourth pair. Ah, okay. Let's proceed to the other figure, which is the T568B cable pinups. Uh, like what we've done here, we are going to identify the color of each wires here. Now let's start. The first um the first pair is always at the middle, and now on this one, the second pair is here, but on RJ45 T568B pin out, the second pair is at the front, is at the front, and the third pair is here, and the fourth pair is here. Okay. Now that is the color of wire arrangement on two different cable pinouts, T568B and T568A. So um, eh, to make a RJ45 with a copper straight through, the both end of the wire should be um, should be both T568A or T568B. But if you want to make copper a a crossover copper cable, the other side must be T568A and the other side is T568B. The straight through copper cable is used for connecting host and intermediary devices, while the crossover copper cable was used on connecting the same, for example, host to host crossover copper connector must be used, and also if you're connecting to intermediary devices, you must use crossover copper cable. And that's all for this activity. I hope you like it, and um, I hope you understand something and learn something from me, and thank you for watching. So for this activity, we are going to identify if the fiber optics terminology is multimode or single mode. Now let's begin. It can help travel approximately 1.24 miles or 2 kilometers per 200 meters when or 2000 per 2000 meters. It is a multimode because multimode is shorter can travel on shorter distance than single mode. Then the next the next terminology the next is uses light emitting diode as a data light source transmitter. It is multimode. Uses lasers in a single stream as a data light source transmitter. It is a single mode. The difference between single mode is the data travels on a single stream of light source transmitter, while the multi-mode is multiple lights and multiple lights the data travels. Then next is uses to connect long distance telephony and cable TV applications. It's single mode because as what I said earlier, multi-mode can travel in a shorter distance, and single mode is a greater distance than multi-mode. And it has a keyword long distance, so it should be single mode. It can travel approximately 62.5 miles or 100 kilometer or 10 100,000 meters. It is a single mode because as we can see, it is it's a very far distance. Next is used within a campus network. It's a multimode. You know what? You know why. So let's check. Okay, it's correct. And now, thank you for watching this video. I hope you like it, and I hope you learned something from me and you understand what I've said. So thank you for watching. So on this activity, we're going to assemble the frame field. Okay, let's begin. This one, this one will serve the header. This is the header of the frame. Next is the packet. The packet data. It is encapsulated with the header and trailer. Let's check. Okay, it's correct. The header will compose of 4 different parts, and the trailer composed of 2 parts, and the packet data composed of 1 part, which is the data to be encapsulated. What is the first part of our header? The first part of our header is the frame start. It is the frame start flag, which identifies the beginning of our frame. Next one is the addressing. What's the addressing? Addressing is the MAC address, and IP address that will serve to find the destination of this frame when it proceeds to the physical layer. Then the next is I think it's the control. Let's check. Oh no, it's not a control because it must be type first um because type will distinguish the unlayered tree, unlayered tree, unlayered tree, LLC. Let's check. It's correct. Next one is control. It's um the QoS, quality of service, or flow control to for this whole encapsulated packet. Next is the error detection. Error detection will serve us to detect error when the packet was sent, the frame was sent. So the check, correct. Then the frame stop. Frame stop is like the frame start. Frame start is a flag to determine the it's the beginning, and frame stop is also a flag to determine that is the end of the encapsulated packet, which is frame. Let's check. So it's correct. Our we are successfully we are successfully assembled the missing pieces of these frame fields, which frame fields composed of header, packet data, trailer. This whole data is the encapsulated packet comes from encapsulated segment comes from encapsulated segment is comes from encapsulated data called segment, encapsulated segment called packet, encapsulated encapsulated packet called frame, and the frame becomes a binary that will flow to our media. Header composed of frame start, addressing, type, control. The data composed of the data. The packet composed of the data, which then the trailer composed of error detection and frame start. Now let's proceed to the second figure. Second figure is we're going to do a drag and drop activity, uh, which we're going to drag these terminal terms to its unique description or specific description here. Now let's begin. It contains the IP header, transport layer, PDU, and data. It is the data because the data contains IP header, transport, PDU, etc. It composed of everything. The next is identifies the layer 3 protocol used by the LLC. It is the control. Okay. Oh, it's not a control. It's type. The control is the flow control. Okay, I forgot. And let's check. Okay, last two. Marks the end of the frame. It's the frame stop indicator flag, as I said, as what I've said before. I Next one is identifies source and destination host and MAC address. It is addressing. It will identify IP addresses. Uh, it will identify MAC addresses. Okay. Okay, so thank you for watching this video. I hope you learned something, and I hope you understand what I've said, and peace.